Hello, welcome to our channel for R programming. In this video, we will talk about fdistribution and ftest for hypothesis testing on variance using R. So first we will introduce fdistribution and ftest theoretically. So we know if two independent random variables and each of them follow chi-square distribution with n and m degrees of freedom, then the ratio of these two variables divided by their degrees of freedom, so this division called fnm is said to have an f distribution with n and m degrees of freedom. So f distribution is closely related to chi-square distribution. And we know chi-square distribution is closely related to standard normal distribution. So say if a random variable x follows standard normal distribution, so its mean and standard deviation is 0 and 1, then x squared, the random variable of x squared it has chi-square distribution is 1 degrees of freedom because x squared is one variable. And if we sum several chi-square distribution, then the result is also a chi-square distribution, and the degrees of freedom is the summation of all degrees freedom from each chi-square random variable. So that's why if distribution's random variable has also only positive value possible, because it is a division of two chi-square distribution, and chi-square distribution is a square. The random variable is a square of a standard normal distribution. So there is no negative value for f distribution and chi-square distribution. So if we look at these two figures, both have f distribution, and this is a density curve for f distribution. So if we want to test f distribution against a null hypothesis, and the null hypothesis states that two variables are equal, so this is called ftest, and we get the sample from two population, and we get the sample variance from two sample. Then the ratio of these two sample variance follows f distribution if the population variance are equal for these two variance, right? So this is a two-sided test for f distribution. So we find that these two critical values first, called f half alpha and f1 minus half alpha. If we define significant value, the test is alpha. Say for alpha is 0.05. So here, this critical value is t 0.025, and this is t 0.975, because 0.025 will leave the area to the right. This white area is 0.025, and same for this white area. And for the one-side test, we will find that this critical value equals alpha area to the right. So say alpha is 0.05, so this critical value is f 0.05. So if the sample test statistic, the value is located here or here, so we say the test is significant. Same for the one-side test. If we get the sample, calculate the statistic, and it's located in this area, so we say the test is significant, and we reject the hypothesis such the two populations variance are equal. So this is the ftest. So this is null hypothesis, two variances are equal. Then the sample variance division, F follows F distribution with n minus 1 and n2 minus 1 degrees of freedom. So we say an example that there are two samples which will be used to test the population variance are equal. So we get the sample size for the first sample is 12 and the second sample is 10. These are two independent samples from two populations. And we get the data and the mean value. Also, we can omit the mean value here, to not use the mean value. And the standard deviation of the sample 1 is 4. And the standard deviation of the sample 2 is 5. So we assume that the two unknown population variances are equal. The question is, can we be justified in making this assumption? So the question is, we will do hypothesis testing if the population variances are equal. And we use 0.1 level of significance. So here alpha is 0.1. So we let sigma 1 square, sigma 2 square be the population variance. And the hypothesis, for the null hypothesis, H0 is these two population variances are equal. And alternative hypothesis in the test is these two populations not equal. So this is a two-sided test. And we get the alpha level 0.1. So first we have to find the critical region. So we find the critical value if half alpha is 0.05 for 9 degrees of freedom F distribution is 3.11. And we can also find if 0.95 with the degrees of freedom 11.9 is 0.34. If you look back. So this is two-sided test for this problem. So we find critical value if half alpha. So this is 3.11 and we get f 1 minus half alpha. So this is f is 0.95, right? So this is 0.05 for 11 and 9 degrees of freedom. So this one is 0.34 and this is 3.11. So if we find the test statistic from the sample in blue area, then the test is not significant. If in the white area, the test is significant, right? So we have found critical value to critical value now. So next we get the sample, because sample we have standard deviation for sample 1 is 4. So the sample variance is take square, so get 16. And for the second sample, standard deviation is 5, so we get sample variance is 25. So next we get a sample test statistic. This lowercase f equals division of sample variance. This equals 0.64. So you can see 0.64 in the white area, right? Because here is 3.11 and here is 3.34. 0.34. So in this example, we do not reject H0 and conclude there is insufficient evidence to say that the variance differ. In other words, we will hold the null hypothesis that the population variance are equal, right? So next we will show how to do these kinds of f-test in R. First, there are two functions important to using f distribution in R. So this is PF and this is QF. PF is for the cumulative probability function. So if we look at this figure again for the F distribution, this is density curve, probability density. So this white area is called cumulative probability, because this is the integral of the density. Density is the derivative of the cumulative probability mathematically. So this white area is the integral of a division of this curve. So this area and this curve called cumulative probability to this value. So this is the critical value f alpha n. So we say the quantile value is this value and the p value is the cumulative probability is pf with this q. Q is this value. So if we using R 3.11, so we just fill in pf 3.11, 11.9, then we will get 0.95, right? And QF is the opposite operation of PF. It is used to find the quantile value from a given cumulative probability. So say we know this cumulative probability is 0.95, then we set 0.95 here and 11.9 degrees of freedom. QF of this parameter will get 3.11. So next we go to RStudio to do t-test for this same example. So this example will be written here with the same information for the true sample and the standard deviation. And the question is, if we assume that two population variance are equal, can we make a justification from the sample, right? Use alpha 0.1. So calculation is quite simple in R. We just calculate this variance first. So we have standard deviation. So we calculate this variance from the sample. First is 16. Second variance, sample variance 25. So we want to calculate the quantile value, critical value. Here is the critical value for f 0.05, 11.9, and f 0.95, 11.9. So because the QF function is used to calculate the critical value from this cumulative probability. And for the critical value 3.11, which means the cumulative is 0.95 probability here, right? And for the critical value here, if 0.95, then which means the cumulative probability is 0.05. So in R, if we want to calculate the critical value, we have to use QF1 minus this small area. This is to the right side, because the cumulative probability is to the left side of the critical value. So this is the right side of the critical value, and this is right side of the critical value. So we have to use 1 minus both. So critical value 0.05 is 3.10, right? And critical value for the 0.95 is 3.34. It's very almost the same as the handwritten calculation we showed before. So next we will calculate the sample statistic. It is actually the division of two sample variance. So sample variance is 16 and 25. So we get is 0.64. So the result is we do not reject H0 because this sample statistic is between these two values. If sample statistic is larger than this value or less than this value, we will reject the null hypothesis. So, right, because we get a sample value, sample statistic 0.64 almost here. So these two critical value. So just repeat process. So we get the sample, and first we'll calculate the critical value. And in R, if you use the Q function, QF, because QF is input is the cumulative probability. So for the critical value, leaving this area to the right, we have to use 1 minus this right area probability. So this is which the result is the cumulative probability to this critical value, right? Then calculate the sample statistic, then compare this statistic with 2 critical value. If inside these 2 critical value, then for the two-sided test, it is not significant. If outside this range, it will be significant and will reject the null hypothesis. Thanks for watching.